Okay, in this video I'd like to discuss where power series start. Now I mean like where does it goes from n is equal to 0 to infinity or something like that. So first of all let me define a power series. I'm going to say that y is equal to the sum from n is equal to 0 to infinity of a sub n times x to the n. And in another video I showed you how to differentiate a power series. So I'm just going to differentiate this straight out and get y prime. So y prime is going to be the sum from n is equal to 0 to infinity of a sub n times x to the n minus 1. Similarly, y double prime is going to be the sum from n is equal to 0 to infinity of a sub n times n minus 1 times x to the n minus 2. And look where all these power series start. They all start at 0. However, well, there is no however. And what if we write out these power series? What if I write out y prime, y double prime? Okay, so I'm going to say that y is equal to. Now, how we do this is we put in the current value of n into the sum, and then we increase the value of n, and we add the next term onto it, and we keep going until we hit the top term. So in this case, it's an infinite series, so there is no end really. So it's going to be the following: a0 times x to the 1 plus, or a0 times x to the 0, excuse me, plus a1 x to the 1 plus a2 x to the 2 plus a3 x to the 3. In actual fact, I'm just going to go to the third term, which is an actual, well, up to n is equal to 3, excuse me, which is the fourth term. So y prime becomes, I'll differentiate this, we're going to clearly get 0 plus a to the 1 plus 2a2x plus 3a3x squared. And finally, if we differentiate y double, or not differentiate, if we expand y double prime, we're going to get the following. Of course, like, because this is a constant, when you differentiate it, it just goes to 0. Like so. Alright, now if you look very closely, you can see that for the first derivative, the first term was 0. For the second derivative, the second term was 0. The nth derivative, the nth term is equal to 0. Alright, so if we go back up here, we can rewrite these. We can say that this one here is the same as n is equal to 1 to infinity. And this one is the same as n is equal to 2 to infinity. Alright? What else do I have to say about that? No, I have nothing else to say about that so far. Now the other thing I'd like to say about is that you don't always have a power series of that form. Alright, you don't always have a power series of that form. So for example, if you have a power series of like so, if you have a power series like this, y is equal to the sum from n is equal to 0 to we'll say 3 of a sub n x to the n plus r. Let's differentiate that. And look, r is just a number, it's a constant, but it's not a function of x, we'll say, but it's still something in the power. So y prime becomes the sum from n is equal to 0 to infinity of a sub n times n plus r times x to the n plus r minus 1. Similarly, y double prime becomes the sum from n is equal to 0 to infinity of a sub n plus r minus 1 x to the n plus r minus 2. Oh, it's a minus 2. Alright? And if you look closely, you can see that no matter what happens, you're still going to get, even if n is equal to 0, r is going to be non-zero, so you'll never get 0 terms. So in the case we have something else in the power, then some will say of 0 for we'll say the second derivative, the n is equal to 0 is not equal to the n is equal to 2. Alright? So I think that's all I need to say about that. Okay, so thanks for watching. Please pass it on to your friends and subscribe to my channel.